Good afternoon. The other day, last lesson, we had a look at bearings, both compass and true bearings. Today we're going to extend that a bit and have a look at some bearing problems. Now, while we're doing this, these are worded questions. What I might do is try to adopt a practice which we're starting to do in the maths department of picking out and highlighting important words as we have a look at this question. So if I read this question, the example says using a compass bearing and trigonometry to calculate a distance. So that in itself gives me an idea of what I'm doing. I'm calculating a distance. Okay, so a ship sails for 25 kilometres in a southwest direction. So 25 kilometres in a southwest direction from a port A. Find the distance of the ship is south of its starting point. So they're the words, I guess, that we need to have a look at. We've got a ship which is sailing. It's going to go 25 kilometres in a southwest direction starting from point A or port A, and we need to find the distance south of its starting point. So they've already done a diagram for us here. Then we have a look at what they've got over there. We've got our ship started from point A. It went 25 kilometres southwest, so that gave us our direction, 25 kilometres southwest. And now they're asking us to find the distance of the ship from its starting point. So we're trying to find X here. That's the distance south of its starting point. So it's not worried about how far west it is, etc. It just wants to know how far south it is. Okay, so let's do what we normally do. What we're going to do is we're going to find our angle, which we've got up here. They've put that in for us. So our angle here is 45 degrees. Southwest is 180 plus another 45 in there. 45 degrees in our triangle. Now that we've identified theta, we can label the other side. So let's label opposite the hypotenuse is H, and then opposite 45 and adjacent to our angle. So now we look at that, what we're looking for. We've got our hypotenuse of 25 and we've got X next to our adjacent side. So we've got A and H, so we're using car. So we've got cos theta equals A on H. Substituting in our numbers, cos 45 equals A, we'll put in X on 25. Now we're trying to find X. X is on top. So when we rearrange that, we get X is equal to 25 cos 45 degrees. Okay, so let's put that into our calculator, which we'll pull up. And if we do that, 25 times cos 45 equals 17.67. 17.67. As the arcs told me, find the distance of a ship in south at its starting point. It hasn't asked me or hasn't told me how many decimal figures, so I'm just going to come back to my calculator, put 17.677, and then what I might do is I might round that to 2 decimal places, 17.68 kilometres south. So finishing off, it's a worded question, so we should answer in a worded way. The ship is 17.68 kilometres south of Port A, or its starting point, south of point A, which is its starting point. Okay, let's have a look at our next example. says using a true bearing in trigonometry to calculate the distance, so very similar, but using a true bearing instead of a compass bearing. So let's do that again with our highlighting what words are important, if I can get it to stick. A ship sails 43 kilometers from port X on a true bearing of 326 degrees. Find how far the ship is west of X. So they're the important words, I guess. 43 kilometers from point X at a bearing of 326 degrees. Find how far the ship is west of point X. Now again, they've given me a diagram. What I'm going to have to do now is make sure it's in a form that I can use. So let's have a look. We have got 326 degrees around there. I'm looking for how far this ship is west. So what I'm looking for, if I finish my triangle, I'm after this distance here. So I'm going to label that X. And then now what I need is I need an angle. Now I've got 326 all the way around there. West, I remember, is 270. If I put those degrees in just to remind us. And so they, the angle in here, which I'm going to call theta, we're going to go theta is equal to 326 degrees minus 270, which is the degrees to get me to west, equals 56 degrees. So my theta in there is 56 degrees. Let's have a look now. So again, I've got my angle in. I'm going to have a look, and my angle is here. What I'm going to do is I'm going to now label my side. So opposite the hypotenuse, the hypotenuse opposite right angle. Here's my H. My angle's there, so this one is O. Again, the one next to the angle is A, which is what I'm looking for. So this is very similar to the last one. Once again, we've got K, and we've got cos theta equals A on H. Cos 56 degrees is equal to X on 43. X equals 43 cos 56 degrees equals, going to my calculator, 43 times cos 56 equals 24.045. Once again, it hasn't asked me to give it to any particular thing. This time I might write down, I might do it to the nearest kilometre. So I'm going to say the ship is 24 kilometres west of Port X. Okay, let's have a look at our next question. We've got two more. Next one, example using trigonometry to find a bearing. So again, this is not one of our problems that we've seen. It's already telling us we're going to find a bearing. Again, if we just highlight those things that are important, I think this is very, very good practice for you guys. Now we've got town A. It's 46 kilometres east and 73 kilometres south of town B. Find the true bearing of A from B to the nearest minute. So they're all the things that we need to have a look at. Again, they've done a diagram for us. Let's go and decipher it. So what we're after in the first instance is just make sure we understand what we're doing. We need the true bearing of A from B. So they've put our axis on B, which is all very good. We've got our distances, 46 kilometres east and 73 kilometres south. So the angle that we are after, we need an angle which is going to go from here around to here. So what we're going to have is we're going to have 90 to get us to east, and then we're going to find this angle in here, theta, to add it to that to get our true bearing. Okay, so again, now we've identified where our angle is, where our theta is, which is in here. So we can then label our triangle. So our hypotenuse is opposite the right angle. There's our H. Our angle is there. So we've got O there and A here. Now what we can see this time is we've got numbers against O and A. So we're using TOA. Tan theta equals O on A equals, substituting our numbers, 73 for O and 46 for A. So theta is simply tan minus 1, 73 on 46 equals, going to our calculator, we want our second function, tan, and then I'm going to use brackets as best practice, 73. I'm going to use my fraction over 46, close my bracket, equals 57.78. Now what I'm going to do is I'm not going to worry about writing that down. I'm going to come up here and push my second function. Remember, on this calculator, the change, I need to push the dot degree. On a abacus, I don't. So let's push that. 57.47. I'm going to quickly go back and see what that says. In 0 minutes. So it's equal to 57 degrees, 47 minutes. Just very, very quickly, I hope, putting that on an abacus calculator. If we use our abacus calculator, then we're going to, and we can come up with tan minus 1, so tan, sorry, my apologies. Second function, tan minus 1, it's already got its brackets up there. I use my fraction, that's D on E, 46. I want to push that to get me away from that. Close my brackets, equals. Now to change this one, I just have to push this DMS backwards and forwards. It'll change it for me. You can see it's giving me exactly the same answer. Okay, my last one, a fishing boat, left port. Let's get out, once again, we're going to highlight the important bits in the question. Fishing boat, left port, and sailed on a bearing of 128 degrees for 30 miles to a fishing reef. How far is the reef east of port? Answer to the nearest nautical mile. Okay, so again, we've got a diagram given to us for us. We can see that we've got a fishing boat which has gone, there's our port. The fishing boat has gone 128 degrees. So we've got 128 around there. Again, we have 90 degrees to there. So we have got our theta in here is theta equals 128 minus 90 equals 38 degrees. With its axis for how far is the reef east. So what we're looking for is this distance in here. X, we're looking for how far it is east. There's our right angle there. So our angle, once again, if we're highlighting things, our angle's in here, which therefore, when we look at it, gives us our hypotenuse is over here, opposite the right angle, and then this, our angle is in here, so this one is A, this one is O. We've got numbers against our hypotenuse, and we're trying to find the adjacent. So once again, this is a cos theta is equal to A on H. So cos 38 degrees equals x on 30. X equals 30 cos 38 degrees. Again, I'll start off this time using the abacus. 30 times cos 38 equals 23.64 miles, and it's actually the nearest nautical mile, so I'm going to round that up, equals 24 miles. So I should answer that with the question. I'm sorry, the reef is 24 miles east of port. Okay, so that's all the questions that we've got today, all the examples we've got today. Have a look. There's some questions there in New Century Maths that you can do, and some questions there in Oxford. For the Oxford ones, I will put the answers in. After that, the New Century Maths, I haven't scanned those in. If you've got any questions, let me know.